hope everyone's enjoying the afternoon. We've had a really amazing day so far. I've been really enjoying the talks. My name is Yulia Startsev. I am going to talk to you about side effects in UIs. The talk title also varies, as you can see from the title. I work at Mozilla. I'm an engineer on the debugger. Just to show you what I'm talking about, here is the Firefox browser. We have the Mozilla homepage. And down here is the thing that I built with a couple of other people. It's the debugger. And you can see we've got here in the center panel a representation of code that is on the page. On this side panel to the left, we have a source tree. And to the right, you see we've got watch expressions, which evaluate as you run your code through, like, for example, when you pause your code and you're stepping through it, the watch expressions get populated with anything that you say. I'm interested in this variable. Please show me what its value is as I step through it. We've also got breakpoints and a call stack and some scopes. If some of you are familiar with Firefox and you're running the stable version of Firefox, you probably haven't seen this panel. This is new. Yeah, and I'll tell you a little bit about why this is new, how this is new, and what's been happening with this panel. But first, I would like to just tell you a little bit about debuggers in general and what I do. So the debugger, as it's written now, is in fact a website. It's a standard HTML, JavaScript, CSS website with a JavaScript Node.js backend that talks to a C++ bytecode emitter. Here we have the project running in its own browser instance, and it's running next to another website, which is a to-do MVC, which is something that we call the target, or in terms of the language that we use at Firefox, it's the debuggee. We have the debugger and the debuggee. And a debugger is essentially a program that runs alongside another program that it's listening to, and it's listening to certain events, for example, breakpoints, debugger statements, at which it pauses the execution of the code and allows you to inspect what's going on in your code. So my daily work looks something like this, with a debugger website, debugging a debugger website, which is debugging a target. On a day that is a little bit more complicated, it looks a bit more like this, where I have a debugger panel debugging the debugger, debugging the debugger, debugging the target. And if it's really difficult that day, then I even have the debugger browser toolbox, which in fact debugs the entire Firefox browser, because the entire Firefox browser is built with web technologies. So you can use the debugger to debug the Firefox browser, the Chrome, the panel, everything. That's a hard day. When I'm talking about what we're working with in terms of data coming back from our server, is let's say you're writing your code, you're writing JavaScript, or maybe you're writing Clojure, maybe you're writing Elm or something else, and you see something like this from your editor. What we see on the debugger looks more like this. This is the bytecode emitted from our engine telling us what's happening in your code. So we're accessing a property A in a single line on from the object X. And that property is accessed at instruction number 4 there. There's a swap. We're ignoring things, popping, retrieving the value, which is what's being returned. If you're working as a front-end developer, chances are this is something that's not that easy to read, and it slows down your work. You could definitely learn this. Everyone can learn how to read this, but it just slows everything down. It's difficult to work with. Back in the day, and this is probably, for most of you who are working with Firefox, the stable edition today, you're probably used to a version of our UI that's written in something called Zool. So Firefox is pretty old. It's the code base going to the oldest code is I think around 30 years old. Firefox started off as Netscape before Netscape was open sourced and made free. And we still have some of that code in there. So that means we have quite a bit of history. And Zool is actually something from the mid-2000s. It was introduced because HTML and CSS wasn't able to position things very well. So we introduced Zool as a way to have more precise positioning of our components so that we could do things like alert boxes and the debugger panel and complex UIs, but still be somehow close to HTML. This became obsolete pretty quickly because the HTML standard went forward, and so did CSS3 came out shortly after. And the other problem with this is that everything that was written in Zool was object-oriented. Okay, why is that a problem? Why is it a problem to have UIs written in an object-oriented fashion? Let's say you've got a component that is interested in a piece of data. It's interested in displaying a piece of data and modifying it. For example, the UI breakpoint, the UI of the breakpoint. You want to add a breakpoint to a specific line of your code. You just click and it gets added. Great. So you've modified the list of breakpoints, you've added one, and you've displayed it. What's the problem? Well, we have another representation of that breakpoint, and that's in the breakpoint list, which is in the side panel on the right. We'll see this in a second. What happens if you uncheck this breakpoint, or you want to delete it, for example? Then suddenly you've got two views that need to be kept in sync with the same piece of data. So instead of having one component, you've got two components that are listening to the same thing. And let's say this component says, do this and change it and then give me back the information. And then the other component says, oh, do this other thing and change the data and give me back the value from that. So suddenly the data is different and component 1 and 2 are out of sync unless you do something like a subscriber and you're doing an updating model on just this one piece of data just to get it to work. Okay, you can do that. But what happens when these two components are also listening to another piece of shared data and they're displaying that differently? Then it starts to get complicated. Then you get to the situation that we got into with the debugger, which was nobody could change the debugger code. It got so complex that no one knew what a certain intervention in a piece of the code base would result in terms of the rest of the state. We learned from it, and I think many people who do front-end UIs, have learned very similar lessons. It's that maybe object-oriented UIs aren't the best solution. Maybe there's something else. What else can we do? Well, I'm talking at a functional programming conference for a reason, right? The answer that we came to was along the lines of functional programming. But how does that work with UIs? And why would it be a problem to work with UIs? So just narrowing our focus on one attribute of functional programming, which is a pure function, we have an input and we have an output. A key aspect of the pure function, like it doesn't matter what happens inside of that function. It's a black box. It doesn't matter. But what does matter is that the input and the output are clearly just, they're very clear. You put something in, something comes out. What shouldn't happen is there shouldn't be a side effect, or it's not pure. Okay, what does it mean to have a side effect? Let's take a look at it in JavaScript code. Super simple stuff. We have a function, square of a. You pass in a number to a, and then you multiply it by itself, and you get the product out of it. This is a pure function. Let's make this a function with a side effect. What does that look like? Here we have the same function with a side effect, console log. A console log is a side effect because it affects the global state of the program. We're outputting something that has nothing to do with the output of this function. We're modifying global state. And when we're talking about front-end UIs, let's say something super simple, like you click on something, let's say that's an input, but you want to update the DOM from that. Same story, updating the DOM is a side effect. So if you're writing a functional UI, how do you do that without side effects? And the answer is, side effects aren't really the issue. The issue is side effects that you don't understand, side effects that you can't control. You can, in fact, have most of your code written in a functional way and just deal in really clearly defined areas with your side effects. And that's exactly what a number of frameworks have done. So just to point out one thing, JavaScript, yeah. Some languages help you deal with side effects from the get-go. Some languages try to help you. And then there are those that set everything on fire. And I am talking about JavaScript. So I like JavaScript. I'm a really big fan of JavaScript. I think it's a really interesting environment to work in because it's kind of like a blender. You get ideas from everything. You get ideas from functional programming, from object-oriented programming. You get ideas from database theory. You get ideas from all over the place. And that's great. But there are some drawbacks to this. OK, so just understanding that JavaScript has drawbacks, let's just talk about what does it mean to have side effects, like clearly controlled side effects in your UI. There are two places that you might have side effects if you've done everything else functionally. These two places are probably unavoidable, with a few exceptions. There are some ways to avoid this, but these are the two places. The user input and output is probably going to take place as a side effect, and the asynchronous calls will be side effects. To deal with the first one, because it's a simpler case, let's take a look at a really good solution that's been that's developed in a number of different frameworks, not just React. And this slide, yeah, this is the slide we want to look at. This has been developed independently in a number of different frameworks and languages, etc. Elm has an implementation of this. It's called Fold P. In React, it's called Flux, and there's an improvement on it called Redux. It also exists in a wrapper of React for Closure, and I believe part of Flux was inspired by that wrapper. So this idea of having a central store is pretty common for dealing with this problem of managing the side effects from the UI and keeping everything else functional. Let's take a look at how this works. So the most important thing that we've got here is the UI itself. The UI, let's have a concrete example, like you click on a button. That's a really concrete interaction with the UI. What that'll do is it'll dispatch an action. What is an action? An action is something that describes what happened. Let's say you've toggled a button. Earlier we saw the breakpoints, and there's a check mark that says that's enabling or disabling that breakpoint. So we say enable breakpoint or disable breakpoint. That's our action. It's a simple string that's in the type. There's a attribute type, and we've got a simple string that says enable breakpoint. And the action creator says enable this specific breakpoint, and it passes that to the dispatcher. And the dispatcher takes that action and says, OK, we're going to enable this specific breakpoint. And it passes that as a message to the reducer. The reducer takes a look at that message and says, OK, I have this list of potential things that I can change. But in this case, I'm going to change the breakpoint. I'm going to enable a breakpoint. And that means taking this piece of state, combining it with the new information, and returning a new state. We'll take a look at the code for this in a second. I just want to explain the concept for this before we get into it. So this alleviates a lot of the problems that we saw in object-oriented programming. It also allows us to make our code very testable because everything else is done functionally, so we can just pass what we need in and not worry too much about side effects. Our side effects are all happening in one place. Fantastic, like this is great. But there's the other problem, which is having async requests. Now, the purpose of Redux, what Redux is built for is for tracking application state. It's not built for tracking every little minute detail of your program. However, when you're making an asynchronous call, by default, you need to track state, because there's a beginning to that asynchronous call and you're waiting for a return. So that introduces, and on top of it, it's causing a side effect. It's causing a side effect in the database. Or maybe it's causing a side effect in a worker, or something like this. It's happening outside of your application. It's doing something to the global state of your application that you have no control of, and that is not being handled by the case of the central store architecture. So it looks something like this. Fetch is an API, a web API. Also, there's a misconception in JavaScript that it's asynchronous. JavaScript is not asynchronous. JavaScript is totally synchronous. What JavaScript does do is it talks to services outside of itself, such as web APIs. Or if you're working in Node, it's going to be talking to something like a C++ library. Those are asynchronous because they are processes running on their own, but the language itself is not. So what do we do? Where do we put workers? Where do we put the server? Where do we put other things that we need to talk to in order to get the information that we need in order to update things that we need to update? Before we get into this, so there's a lot of, I'm not too sure what everybody's experience is, so I want to make sure that we're all on the same page with what I'm talking about. So a really quick refresher on async in JavaScript. We're going to talk about promise, async await, and generators super quickly. If you have any questions about these later, please feel free to talk to me about it because I will go over this rather fast. So a promise is a object that you can instantiate that will then send something to the promise middleware. Not promise middleware, sorry, the promise web API. And what it looks like is like this. You instantiate it with a new keyword, and it has two callbacks, which are functions that are passed into the promise. Resolve and reject. You don't have to define them yourself. They're just there. And let's say your asynchronous code succeeds. Then you resolve with the response of that successful code. You might be doing this with like talking to some backend API or a worker or something like this. And if it fails, you reject with an error. When you use a promise, it has to be instantiated because when you just say new promise, it doesn't actually run. You have to run it somehow. So you have to say, you have to actually use that promise. And you can, there are two methods on it, then and catch. The then will allow you to take the results that you resolved with and continue doing work on it. And the catch will allow you to throw an error, for example. This will allow you to do some kind of error handling. Okay, another quick refresher for those of you who might not be familiar with how web APIs relate to the JavaScript call stack. Let's say you've got a function that calls a promise. It'll look something like this. So the stack, the first function is on the bottom, then the second function is running, and it says do something with this promise, and then there's a promise. And that promise, once it's instantiated, it actually gets moved over to the promise API, and it's put there. So it gets popped off of the stack right away. Right away when it's instantiated, it gets popped off. And it does the work inside of the web API and gets passed into the event loop. It can't do anything more at this point until the call stack is emptied. So once that's emptied, it passes its resolve callback into the call stack. That's when it can actually do something with what it's done. That's when you can call then on a promise. You can't do it before then. So essentially, like if you've got a promise running and you're wondering like, oh, I've done something after the promise, but it's happening before the promise resolves. This is why. It's also the same reason that, for example, you might have seen set timeout 0 in some code. That is, in fact, a hack. It's a way to get out of the call stack and then get put after the call stack empties so that you can do your work after everything is finished. It was very useful, but now the promise is much more useful for this. Promise is a dedicated way to do this. If you want more information, there's a great video about this by Philip Roberts. He explains it in great detail, and he also has a great application that helps you understand it better. Okay, so we've seen how to use a promise. Let's take a look at what the problems are with using promises. Since you can't do the work that the promise has been doing unless it's inside of the then chain, you have to do everything inside of that chain. You can't do anything like outside of it. Everything has to be inside of this chain of thens. This can be really hard to read, especially if you've got a deeply nested series of things that have to happen. Like let's say you've got two promises inside of a promise that need to complete before the next step can take place. How do you do that? It gets very complicated very quickly. So there was a new syntax introduced, I believe, in ES Next. It might have been ES 2017. I can't keep track of the numbers myself, so this is new. You can use it already. It's really interesting. It cleans up your code quite a bit because you can just say, you can use the keyword async and await to say that this function is going to be a promise and it's going to wait on another promise, which is going to be async function. Async function is also a promise, but now so is the something function. They're both promises now. However, you can inline everything. So you can treat asynchronous code as though it's synchronous. This is great. I want to bring up one last thing about promises before I move on to generators, which are not asynchronous at all. Promises cannot be canceled. Once a promise has started, it has to complete, either with an error or with a resolve. Why is that a problem? Well, there's a library that can illustrate this very well. It's called Gremlins.js, and what it does is it takes your project and it randomly clicks everywhere. And you can run it for like 2 or 3 hours or maybe an entire night and see what kind of errors come out of it. And one of the most common errors from this kind of testing is errors that occur from promises trying to complete with faulty data because the data changed and they're trying to do something with it, or maybe something else happened, another promise resolved before the first one did. It's really fun. It's a couple of years old, but I think it still works. It's definitely a lot of fun. Yeah. We'll get back to this in a second. The next thing, the last thing that I want to do in this really quick refresher about async in JavaScript is I want to talk about generators. And generators are not async. They're completely synchronous. What's great about generators is they allow you to pause in the middle of a function. Here's an example of a generator. The syntax is you have a function star. This will define it as a generator. And you've got the keyword yield. Yield is the point at which you pause. And the only way that you can resume is by using the next method on an instantiated generator. So here we've got the ya9 generator. And what it's doing is it's just returning two values. The first time you say next, you get back ya, ya, ya. And the second time you say, give me the next value, you get nay, nay, nay as a value. The third time you call it, you get the value undefined and done as an attribute. Done is true. Great. How does this relate to async await? How does this relate to promises and everything that we're going to be talking about in a second? I'm going to just do a really quick demo. Oh, not yet. I need to finish this part. So generators of functions that can be paused and resumed. Think cooperative multitasking or coroutines. So if anybody's done Python, you're probably familiar with it. I believe this is also existing in a couple of other languages. And it enables a number of applications. This again, more information if you need it, is here. It's a really great text on how generators work in the current JavaScript spec. Okay, so let's do a really quick demo about what does it mean to have coroutines, what's happening, why is this interesting? Okay, so we can just take this. We have a questions generator, and what's happening here is we've got a question, what is your favorite color? And we've got an answer, which is yielding the question. And then we've got yield, you answered, and the answer. Okay, what happens when we actually run this? So, we're instantiating the generator. Oh. And let's do the first next. Okay, we're getting the question, what is your favorite color? Cool. I can answer that question, like so. I've answered it with blue, and it immediately goes and says, you answered blue. So what's happening here? We have the yield question, and it's being assigned to answer. So where is it pausing? It's pausing immediately before the assignment of answer. And next resumes from that point. So answer gets defined by the next call. I completely messed this up like an hour ago. I was trying to remember how to do this demo, and I was like, how does this actually work? Because this was very unintuitive to me. So this is the coroutines in JavaScript generators. You can get two functions to talk to each other using the next and the generator. And that's how async await is actually implemented. Await is a syntactic sugar on top of the promise implemented using this method. That's what this is, and we're going to be using it in a second. Oh, and I can even close this, because we're not going to use that anymore. Okay, moving on. Oh yeah, and if you want more information about generators, Bodil Stock has an amazing video about this, and she actually implements promises using generators. She implements async await using generators. Highly recommended. My slides will go online, so if anybody wants the links, you'll be able to directly click on them. Okay, so let's get back to our initial problem. Asynchronous side effects that occur completely outside of your application, somewhere on a server, somewhere outside. And how do we deal with them? And there's two strategies that I'm going to introduce to you. One of them is thunk Redux, and the other one is Redux Sagas. We're going to start off with a simpler one, which is Thunks. This is, so just a little bit of trivia about the name. It's coming from, it is a term within computer science, it's a term within compiler theory as far as I understood when I was looking this up. And it's coming from initially Peter Ingerman's paper on AGL 60, where he introduces the concept of a thunk. And what he says there is that it's a sub-process, so you've got a parent process of the compiler, and it gets an expression that needs to be evaluated. But it can't be evaluated in the parent process, so you make a subroutine that takes care of that and returns the value, and then the compiler can continue. So thunk is, in terms of English, it's the jocular for to think. So you might say, I thought of it, or you could say, I already thunk of that, or have you thunk of that, or some, I don't know. I don't know how I would use that in English, but it's jocular of that, of to think. So that's just an interesting piece of trivia. The way that it's implemented in JavaScript is, of course, different. It's not anything as impressive as creating a sub-process. It is just a promise, which has some similarity, but. What it does is it wraps the dispatcher part of the architecture that I showed you earlier. So the dispatcher is the thing that goes and says, hey, reducer, you need to make this change to the state. And dispatchers send simple objects to the reducers. Reducers can only accept simple objects. What is a simple object? A simple object is something that has a number of attributes, and they can only be either strings, or they can be numbers, or they can be objects or arrays, but they can't be something like promises. What this does, by wrapping it in this middleware Redux Thunk, is you can now use promises in this. So here's an example of an action creator that's using the promise middleware. We have, as I mentioned, the type basic action. This is the type of thing, this is what happened. What actually happened when we did this. And it's got a message, that's the data, that's the payload that we're giving over to the reducer. And now we've also got this new piece of information, which is a promise. The promise middleware is also coming from Redux Thunk, and what it does is it takes care of any asynchronous function that might be in there. And in this case, we're awaiting some kind of asynchronous operation to complete. Here's the reducer. On the reducer side, Redux Thunk looks like this. You have your switch and case. You've got your case statements, and in a normal reducer, you wouldn't have the if statements inside. You would just have case statements, just a list of things that'll happen and how the state needs to change. However, now we've got if the action status is start, do one thing. If the action status is done, do something else. Now, while you're looking at this, you might be thinking, I can think of another way to write that, which is as two nested switch statements. And this might be feeling a little bit wrong. This might be feeling a little bit like, oh, I don't know if I want to do that exactly. And that's perfectly understandable because reducers should be simple. They're supposed to simplify your code, and this is getting complex. All right, let's talk about, before I walk away from this slide, I just want to mention one other thing. This isn't necessarily a bad thing. Let's say you've got a simple application, and you want to load a piece of data. While you're waiting for that data to load, you want to show a spinner. It makes a lot of sense to use a library like this, where you just have a simple start and done method. You can just say, when this asynchronous function has started, I want to show a spinner or something like this, maybe a cat rolling around in the grass, I don't know. Just show something so that the user doesn't get bored, and once it's done, show them the data. This kind of a library makes a lot of sense. But on something like the debugger, where we've got workers and parsers and servers and everything's running all at the same time, and there's a lot of data processing that's going on, we need something a bit more complex. So we've been looking at Redux Sagas. Sagas are a very popular library. Redux Saga is a very popular library right now. And again, a little bit of trivia. It's coming from a paper that was originally published in the database research community, written by Hector Garcia Molina and Kenneth Salem, or Salem, I'm not too sure. And they wrote a paper about sagas. In the paper, they sort of say, this is a bit of an obvious idea, but we want to just make it official that this is how we're doing things. And they define sagas. They define sagas in this way. A long life transaction is a saga if it can be written as a sequence of transactions that can be interleaved with other transactions. Okay, so if we say that in a little bit more simpler language, we might say something like, a saga is a series of requests that can be composed and can be managed on a fine-grained level. Like each transaction, each request to the database can have its own error handling and roll back, roll forward, and you can mix and match them depending on what needs to happen in that particular case. A word that's missing here that I think is really important is scheduling. One of the most powerful parts of Sagas is that you can really schedule tasks. You can say, this needs to happen at this moment, and if it doesn't happen, fail. Or if it doesn't happen, try again. Or if something happens in the interim, do something else. It gives you fine-grained control over what happens when. And here's what happens with when you've got a Saga inside of a project. So rather than wrapping the dispatcher, it is instead also listening to the actions just like a reducer might. So it's not wrapping the dispatcher, it's just sitting as a layer on top of the reducer. And it doesn't stop any calls from going to the reducer, it just sends its own calls. It listens and it sends. Here's what an action creator might look like from a Saga. This is a completely unmodified action creator. It looks a lot like what a simple Redux project might look like, without any communication with the database. And here's the Saga that goes along with it. So you'll see that we're using generators here. We have function star, and we're using yield. A couple of keywords here. So take every is a way to take every single message that's coming in from the dispatcher, and it's non-blocking. So it'll just take everything. It'll consume absolutely everything. And then put is analogous to dispatch. It's essentially the same thing as dispatch. And of course, you can mix and match await and generators. That's not a problem. To just take another look at what thunks look like, this is what was happening in the thunks. We had a dispatch and a promise, and everything was bound together in a single object. Here's a reducer for a Saga. Rather than having the basic action with if action status start, do this. If action status status done, do that. If action status error, do that. Instead, we have either a basic action or a successful action, or maybe an error action. And you can imagine that rather than having a rather than having a single action that has to handle errors on its own, you can have centralized error handling. You can have centralized promise resolution handling somewhere. Okay, let's take a short break because that was a lot of information. We just went really fast through through promises, through async await, through generators. We also covered how thunks look like in a Redux application and how sagas look like in a Redux application. And this might be a little bit hard to understand. How does this actually apply? Like what's actually happening here? So I have an example. And the funny thing is I've done this talk once before, and I predicted that this bug would occur. And in fact, it did. And I probably put it there. So the problem, we have some spooky action at a distance. We don't know why something is happening, but it's definitely related to our workers. Okay, so let's take a look at what this bug looks like. Here is the debugger running as a website. And you'll see that we have a breakpoint, and it's in a list, and we're looking at this file. So what's the bug? Let's take a look at what happens when we reload. Watch the number line. What happens to the number line? See how it flashes? That's a really weird bug. But it gets a lot worse if the file is bigger than this one. For example, imagine you've got a file that's 80,000 lines long, and this flashing suddenly, you're just seeing it blink, blink, blink. What's going on? So it's really funny because I knew this would happen, and I'm pretty sure I'm the one who did this by accident. because of reasons. The source of the problem is in this piece of code. I've simplified it. So some of you might be looking at this and be like, oh God, it's JavaScript and there's absolutely no type checking. We actually have type checking. I just removed it for simplicity's sake. So the problem is when we call new source. So why does new source happen? New source is the function that we call every time a source is added to the debugger and we want to display it. And what we do is we dispatch saying, okay, just list that this new source is there, and check if it's the selected source. That's what this selected source function is doing. Is it our selected source in this case? Maybe. And then also wait until we check if the breakpoints are there. And you noticed probably that there was a breakpoint on that file. In fact, that bug doesn't appear unless there's a breakpoint. And then dispatch load source map. Okay, what's happening? Let's take a look at selected source and check breakpoints. Here we have two if statements inside of these functions. And they're both doing the exact same thing. They're dispatching a function called load source text. Load source text goes to the parser and says, hey parser, can you check out this file for me and give me back the text for it? And it does that. And it takes a really long time. And we're doing it twice. Now, if you remember the code before, you'll see that there's an await statement on the check breakpoints, but not on selected source. And here we've got load source text. It's happening twice. And a little bit of contextual information. Load source text has a guard statement that says, hey, if you've already loaded the source text, just take the cached version of the text. But since we're not waiting on select source, and it is a selected source, we end up loading it twice because load source text doesn't have the time to come back because it's a promise. It's outside of the event loop. The event loop completes, and then the two promises return, and they're both load source text promises, so that we load the text twice, thus the flashing. Actually, we were loading it 3 times, but oh, it was a terrible bug. I can't believe it actually happened. I knew it was going to happen. So let's, what's going on with load source text? It's used in 2 places. It's really costly. Here's the solution with thunks. Now, I'm doing the really naive solution here. I'm just moving the await statement to the first function. In order to realize that this await statement is really important and it has to come before the second function is fired, you would have to have a comment or something like this. You could also wait on both cases, but the thing is, you don't always want to wait on the asynchronous code because you want to delegate things. You want to say, okay, this process needs to start over there, that one can start then. We don't need this function to wait for everything to finish before we, for example, display something. So adding a wait everywhere isn't exactly a solution. We have to choose. And the only way we can tell a future programmer that we're waiting here for a specific reason is with a comment. But as you can see, you can solve this bug with thunks. Here's the solution with sagas. This is much more complex, but I'll take you through it quite step by step so that you understand what's happening. So we are dispatching. Yield put is analogous to dispatch. And then we've got 3 processes that we're opening up using yield fork. A fork is a way to keep track of a promise that's been fired, but at the same time, not give up control of its instance. So we pay attention, like what happens to that fork? If it fails, what do we do? If it finishes, what do we do? And on top of it, we've got a yield join. And join is blocking. We stop the process from continuing unless all 3 processes have finished, right? And then we say that the source has been added. Once all 3 processes have been completed, we can say, we're done. This is great. Now, sagas give you a number of different methods to schedule your work. There are the blocking methods, and there's a lot more blocking methods than there are non-blocking. You have take maybe, put resolve, and a few others. We're only going to take a look at a couple of them. And also the non-blocking, like to put, fork, spawn. Spawn is equivalent to fire and forget. It's equivalent to promise without the await keyword. So you just say, I don't care what happens to this promise. It can go forth into the world, do whatever it needs to do. And fork is holding on to that instance and saying, it can go off into the world to do whatever it needs to do, but I want to make sure that it actually succeeds. Or it fails, or I want to know something about it. Okay. Just a really quick thing about blocking put, because by default, Saga's dispatch is not blocking, which can lead to some interesting behavior. So if you're expecting to dispatch things and that they'll go in order, they won't necessarily go in order with Sagas. You need to actually block them. And the other thing that I want to bring up are the channels. So what are channels? Channels in Okay, so one major distinguishing feature between thunks and sagas is that thunks are called and sagas decide to do actions. They can decide that a certain function needs to go forward. So a channel is essentially a queue, and you can pull things from the queue. Rather than having the dispatcher called all the time, you can decide, okay, for this specific action, I want to dispatch this. I want to do this work with an asynchronous service. Rather than saying, like, let's say you're typing and you're doing a search with every single keystroke. Instead of doing that, you can say, I only want to take the very last string that comes back from a certain period of time. It makes it very easy to decide when to do work when you've got a lot of actions being dispatched all at once. Okay, let's take a look at an implementation of that with load source text really quickly. Here we've got a channel being opened up, and we're opening a loop, an infinite loop with while true. We pull the payload out of the channel. And remember, channels are blocking, so this is going to block other work. And if the source text exists, yield the source. If it doesn't, call load source text, which is also a saga, and pass in the source. Why does this solve our bug? Well, if you've got load source text 1 running twice, it will actually stop and say, hold on a second, we've already got that load source running. We're not going to pull it again. We're going to wait until that one resolves, and then we'll return whatever needs to be returned. So you stop the process from continuing until the queue is free for the next thing. You don't just keep on running things. Here, I'm going to skip this because this is just an implementation of load source text. It's not that interesting. And let's take a look at something else that we can do with this, because this is really powerful. Suddenly we can decide what happens under certain situations given a certain queue. Let's say we want to do something else when we're loading the source. Let's say we actually want to check if there's an error. So let's say you're loading a source, it fails the first time, you want to reload it. So you wait 1 second and reload it. The only way that you would be able to do this is either if you did a catch block inside of the thunk, inside of a promise, or you handled it in the reducer, which is an anti-pattern. You don't want to handle this kind of data in a reducer. Okay, and let's take a step back. Last thing. Remember these gremlins. They're clicking everywhere. Sagas allow you, and sagas are of course not the only library that lets you do this, but sagas have a cancel method. So for example, here's another bug that we've got. You're loading a source, and you navigate away from that page. So let's say you're just like quickly going back through, you're navigating backwards through your history. If you're doing that and you've got the debugger open, the debugger is going to complain a lot because it's expecting that it's expecting the source to load. But the engine, the SpiderMonkey engine is going to be like, hey, that source doesn't exist anymore. I don't have anything for you. So the promise is going to fail. What do? What we can do instead is we can cancel the source by saying, if there's a navigate action, just cancel everything. All right, a couple of observations before we wrap up. Simple promises are actually sufficient in most cases. You don't even need thunks or sagas. You can take care of it in the action creator with a simple promise and then firing the dispatcher from that. Thunks are useful if you want eager updates and error handling inside of the reducer. So for example, if you have the simple case of a spinner that you want to show while a certain widget loads, thunks are perfectly sufficient for that. Sagas are useful when you're working with complex tasks that need to be scheduled. Because if you've got a lot of different things happening in the code base and you need to be able to keep track, like this is changing, that's changing, this other thing is going to change. If you have this kind of behavior, this makes a lot of sense. There are criticisms of both. They are both too powerful and they do too much. They basically break out of the constraints of Redux. The same can be achieved with simple promises, as I mentioned. And thunks lead to duplication of async logic, and sagas and generators are difficult to read and understand. Sagas and generators are not something that most front-end developers are used to working with. I'm going to skip this. This is basically the same stuff. So Hopefully I got you interested in this technology, and maybe you're even interested in helping us out. This is the link to our project. We have everything on GitHub. We're super friendly, and we're very happy to teach. So just drop by. We've also got a Slack. You'll find all the information here. And thank you. That's it for me.